So let me start off by just giving you a little cartoon. My colleagues, much to my colleagues' dismay, I'm still quite active on Twitter, and actually I find it quite useful. I follow a couple of academics on Twitter who publish quite a lot of research on heat, why it's important, how we can decarbonize it. And I thought this was a fun cartoon for illustrating its importance. In essence, there's a lot of talk now about new technologies that are available to people, solar panels, batteries, and so on. And there's even a thing called the climate dad, which I'm proud to say I'm a fully paid up member of, should be climate parent really. But this is a group of people who stand around at parties and talk a lot about their new electric car or their new solar panels. But in many ways, the elephant in the room is heat and how we decarbonize heating. Heat, whether it's for residential purposes, heating our homes and our buildings, or in commercial and industrial applications, actually represents about 40% of greenhouse gas emissions. So it's a really important area that we need to decarbonize as quickly as possible. So I'm going to talk to you this morning, first of all, about buildings and how we decarbonize heating in buildings, and then a little bit at the end about other industrial applications as well. So heating in buildings, as I'm sure you all know, is traditionally been done using fossil fuels, usually natural gas, certainly in the UK and in many other countries. And in order to decarbonize heating, we need to move away from technologies that rely on the burning of fossil fuels. Heat pumps rely on electricity to power them, and we can decarbonize electricity through renewable technologies, wind and solar, and so we can decarbonize heating that way. I first learned about heat pumps at university, and there is something slightly magical about the technology. And the way it works is illustrated in the diagram here on the slide. Essentially, you take a refrigerant which absorbs heat from the ambient environment, either from air or from the ground, or sometimes from a water body. This is the blue part of the diagram. And even at temperatures of below freezing, -5–6 degrees, there's still heat in the air, and the refrigerant can absorb that heat. It's then compressed as it comes into the building. It's then run through a heat exchanger where the higher levels of heat that you get when you compress the refrigerant, that heat is transferred to either air or water through a heat transfer, and then that's used to heat the house or the building, and then the refrigerant passes back outside through an expansion valve, and the system starts again. And the only energy you need is the electricity that's used to power the pump and the compressor. And because the heat is collected from the ambient environment, nothing is actually burned. The only energy that you need, is the electricity that's used to run the pump and the compressor. And this means that heat pumps can be very efficient. I have a heat pump actually just outside my office here, humming away, which over the 6 years that we've owned it, on average produces about 3 units of heat energy for every 1 unit of electricity that we put into the system. So you're getting efficiencies of 300%, which is much better than you get with a gas boiler, which is typically around 90%. So we think this is a critical technology for decarbonizing heating in buildings. There are others. There's green hydrogen, which you can run through a fuel cell, and that can help reduce greenhouse gas emissions. All the studies suggest it's much less efficient, much more expensive than a heat pump. And so we think that heat pumps are probably going to turn out to be the best technology. So while the technology is more efficient than a gas boiler, of course, that's not the only question. The other very important question is around the economics of the system. Typically, the upfront cost of a heat pump is higher than for a gas boiler. That's not always the case, but it generally is the case still. But then you get better reduced OPEX through the higher efficiencies, and so the total cost of ownership in many parts of the world is actually below that of a gas boiler. This is data from Daikin. It's a couple of years old now, and the increase in electricity and gas prices that we've seen over the last 12 to 18 months has actually increased the differential between heat pumps and gas boilers. So in Japan, South Korea, Germany, but also in the US, Italy, France, the total cost of ownership unsubsidized of the heat pump is now even better than it is shown here. The UK is a bit of an outlier, as you can see here on the slide, where it is still, even with the higher electricity and gas prices, it's still more expensive to run a heat pump than a gas boiler in most applications in the UK. This is primarily a policy choice where we've chosen to apply high levels of taxes to electricity than we have to gas, which disincentivizes the use of heat pumps in the UK. It is something that's being reviewed by the government, but to date, at least, this is still the situation. But with the economics across the rest of the European market and some generous subsidies as well in many jurisdictions, we are seeing an acceleration in the residential heat pump market. You can see here data again from Daikin, the Japanese company that makes heat pumps. You can see the acceleration from around 500,000 units, just under 500,000 units in 2020 to over 7 million units per year in 2030. That's what's anticipated. And recent data that was published by Carbon Brief, you can see here the really quite phenomenal levels of growth that we're getting in some markets. So Belgium, a relatively small market, has grown, has doubled in 1 year. This is from the end of 21 to the end of 22. Still a small market though, around 50,000 heat pumps a year. Poland, a much larger market, you can see a bit further down in the graph, grew 120% last year, more than doubling from about 100,000 heat pumps to over 200,000. And Italy, the largest market of them all, grew only, quote unquote, 37%, and has gone from 360,000 units to nearly 500,000 units in a single year. So really tremendous growth. And again, you can see the UK clearly underperforming as a large economy, still respectable 40% year-on-year growth, but it's still a very small market. It's only around 60,000 heat pumps a year, smaller in fact than the Czech Republic. And if you look at it on a per capita basis, last year, Italy was installing about 1 heat pump for every 100 people. France was doing 1 heat pump for every 200 people, and the UK was only doing 1 heat pump for about 1,000 people. So we've got a lot of work to do to catch up with the rest of Europe. So that's the backdrop in terms of the market, the technology. In terms of our investments and where we're positioned, this is still a relatively fragmented market. My colleague Victoria McLean went to Europe's largest heat pump fair in Frankfurt a couple of weeks ago. 200,000 people attended that fair, 2,500 exhibitors, including many of the companies on this slide. There are actually over 40 heat pump brands in Europe. And while it is fragmented at the moment, it is consolidating very quickly. Just this morning, we heard confirmation of an acquisition by Carrier of a German heat pump manufacturer. So we expect it to consolidate. And we do believe that actually it's the larger manufacturers that will. There are a number of reasons why larger manufacturers are likely to dominate the market. For example, brand is still quite important in terms of conveying quality. Larger companies can provide training centers for installers who are still learning about the technology. Software is becoming a bigger part of the proposition to customers, and that's something that larger companies can invest more into the development of software. And there are economies of scale in manufacturing as well. So we do think that it will consolidate and the larger players will win. Daikin is a key holding for us here, the largest heat pump manufacturer in Europe, and the one with the largest anticipated growth in manufacturing. There are likely to be a million additional heat pumps manufactured in Europe in the coming years, and over half of that commitment is from Daikin. And then the other two, Train which is a more commercial, more focused on the commercial market, which I'll come back to in a second. And then Ariston, which is in our European fund, and is a sort of standard there for the European companies, is also an acquired a German company called Centrotech recently. So those are the three that we think are best placed to succeed in this market. So before I finish, I did also want to talk about industrial heat. This is a market which is a bit further back than the domestic heat pump market, which is clearly inflecting. We've yet to see this inflect in industrial heat. Heat pumps are important here too. In fact, about 40% of industrial heat demand is at relatively low temperatures of less than 200 degrees, which is a part of the market that heat pumps can serve very well. So I mentioned Train, which has technology here. And this is technology that's used in food and beverage processing, pharmaceuticals, pulp and paper, textiles, those kinds of things. You do need higher heats, higher levels of heat in other industrial applications. So in ceramics, petrochemicals, you need higher heat, and you can get that through some of these other technologies, resistive heating, electromagnetic heating, and then the really high temperatures you need things like electric arc technology and plasma torches. If this whole market was to move to electricity from fossil fuels, it would be about $1 trillion market. At the moment, though, it's much smaller. The heat pump market is around a $10 billion market per year. As I say, that hasn't really begun to inflect yet, but we expect that to happen as pressure builds on companies to decarbonize their manufacturing processes. And the industrial heating market overall is around $36 billion currently. But those are both numbers that we expect to grow quite rapidly in the coming years. So the only company that we currently have which has exposure, or meaningful exposure to industrial heat is Sarco Engineering. They're a UK business. Some of you may well have heard of them. Their main business is actually in steam and helping their industrial clients use and manage steam very efficiently. So if you see in this little chart here, that row below the headings, the focus of Sarco is on the steam loop technologies. So once you've generated your steam using fossil fuels, then how you use it, that's where they're focused. But they have got this other business called their electric thermal solutions. And basically what that does is focusing on helping their clients use renewable electricity to generate the steam. And that's where the ETS business focuses. And then they still have their steam business that's focused on helping them use that steam more efficiently. At the moment, their ETS business is about a £200 million a year business, so still pretty small. Spirax overall is about 1.5 billion pound business, so it's a small part of their business, but one that we think is very well placed to capture growing demand from industrial clients who are looking to decarbonize their heating systems. So I hope that's helpful as a little introduction to a new theme that we're focused on, that of heat. And with that, I will hand back to Sarah for questions. Thank you very much.